Okay, we can start. Hey everyone, I'm Bartosz, I'm from Hacken. I will be talking about bridges. I think everyone uses bridge because otherwise it's pretty hard to do anything in crypto. So they are quite important part of the ecosystem. So let's see how they get hacked and why. Okay, so a little bit about me. I work out. Okay, I'm working mostly with layer 1 protocols. So things like new protocol, Ethereum, some layer 2s. I did a lot of audits, found a lot of critical issues, and I work for Hacken, which is Web3 cybersecurity company. We do audits and almost anything when it comes to Web3 cybersecurity. Okay, so let's go to the bridges. There are many types of the bridges. Hybrid bridges, trustless bridges, layer 2 bridges, but when it comes to the security, there are basically three types of bridges from my perspective. We have centralized bridges, we have decentralized bridges, and we have trustless bridges. So let's check every one of them and see how they work from the security perspective. So the first one are the centralized bridges, the most simple one, and the most popular one. Most of the bridges which are in the market are centralized bridges, and also I would say exchanges are kind of centralized bridges. There's usually a single entity or group of entities that very connected with each other, which control the bridge, which control the transactions. Sometimes they don't even need a smart contract to work correctly. So yeah, they are pretty easy to implement. They have low operating cost. They often, almost in many cases, they use Oracle to work. Sometimes, in very rare cases, they use a third-party oracles. But the problem with this is that there's often just a single point of failure. If private keys get leaks, if someone gets access to the server or the oracle controlling the bridge, then usually all the funds are lost. And of course, there is a high risk of rug pull, censorship, data manipulation, because in the end, everything is just controlled by a single entity, so we need to trust it. And it happens even in very big protocols. I've seen $1 billion market cap protocols which still operates on a centralized bridge. And also, what's pretty important, some bridges lie about how centralized or decentralized they are. Okay, they can say we are running 9 validators, but for example, each of them are very connected to each other, so they are not so decentralized. Okay, next type are of course decentralized bridges. Sometimes it's hard to say when decentralized bridge starts and when centralized bridge ends. But let's say that in this case, the decentralized bridge is just a bridge which have a lot of validators, nodes, some consensus running all the bridge operations. For example, they require 5 out of 9 signatures to confirm the transactions. Some of them are more advanced than the others. Some of them are like a different independent blockchain where you have the consensus, when you have stakes, you have punishment for the wrong operation. Sometimes you have some kind of zero knowledge proofs. But in this case, when I'm talking about the centralized bridges, we assume that they have still some number of validators which need to sign something to work correctly. And the pros of such bridges are that this trust level which you have is higher, because right now there's not this single point of failure. Usually there are a few of them. You need to hack few private keys through few validators to actually steal the funds. And the same goes with the data manipulation and all the other things which were an issue in case of centralized one. Okay, and of course the problem is that they are much harder to implement, so most companies don't implement them. And if they do, it's also easier to make a mistake. because there's much more code, and to implement everything, every edge case, it takes quite a lot of resources and time and skill to build. And of course, if you make a mistake in a smart code or in another place, all the funds can be lost. Okay, and the last type of the bridges, the trustless bridges. So those are the most advanced one. Usually they don't require the private key, they don't require validator. They're using just cryptographic proofs to move assets from one protocol to another. For example, we had this Nomad bridge. It was a trustless bridge which didn't require any validator, but they made a bug and in a smart contract and they were hacked. But okay, in general, when you have this trustless bridge, it's the safest type of a bridge from the user perspective because usually there's no third party controlling your funds. You are not behind, your assets are not behind just a single private key. But the problem is they are very hard to implement. Usually, I wouldn't even start without like $1 million budget to build such a bridge. So most of the protocols don't have them. And the current one, the existing implementation, are mostly for layer 2 protocols, which are easier to implement. So yeah, I would say it's still kind of a new thing, but you still can make also a mistake, even if you are using zero-knowledge proof and everything and other cryptographic methods to make it secure. Okay, and when it comes to total value locked on bridges, it's huge. Right now, after this drop in 2022, we are back to almost the top with $25 million when it comes to total volume locked on the bridges. The data is from DeFi Llama. But actually, I would say that it's, if you include the exchanges, which act kind of like a bridges, then this volume is even higher, so a lot of money. So that's one of the reasons why it's so interesting to hackers, to focus on them because so much money are locked there. Okay, let's take a look at hacks which happen when it comes to the bridges. There's quite a lot of them. So in total, right now, I would say around $3 billion were lost in a bridge hacks. So quite a lot of them. Especially in 2022, there were a lot of hacks when it comes to bridges and smart contracts in general. The good trend is that right now there are less hacks when it comes to the issues in the smart contracts. Right now, usually when the hack happens, it's due to some problem with private keys. Yeah, we have a blockchain for so long time, almost 10 years, and still the private key management is a huge issue, and it led to so many money lost. Incredible. Like for example, in this running bridge, they had this issue with private key. They were kind of decentralized system. They had 9 validators, but someone, by using different methods, hacked 5 of them. So, right now after this hack, he was able to control all the operations by bridge, and boom, 624 million were lost. Yeah, same case with many other blockchain, many other protocols. For example, in other protocols like in, let's say, Nomad bridge, we had this was this Trustless bridge, but there was an issue in a smart contract. So there was one specific kind of the transaction which someone found how to exploit, let's say, validation in the smart contract, abused it, then the other people see that this issue exists and everyone started to abuse it. But in general, when it comes to the smart contract issues in the bridges, they're very similar to to issues in any different kind of smart contracts. The problem with bridges is that they are usually more complex, especially if try to implement trustless bridge, if you want this cooperation between multiple protocols. And when you need to support multiple number of tokens or NFTs, that's quite a problem, and it takes a lot of time to implement such smart contracts correctly. So even if the issues are pretty similar, it's still, I would say, easier to make them in a bridge. So yeah. Let's talk a little bit about the private keys, because right now it seems to be this, one of the biggest problem in general when it comes to the bridges. So the problem is, of course, it's quite complex to ensure the safety of a private key. On the one hand it is, on the other hand it isn't. Let me explain in a second why. The biggest problem is when it comes to who's responsible for the private key. Because you have the company, you have a server, you store a private key, so who should do it? Should it be done by the developer? Should it be done by the CEO, CTO? So in many cases it is a problem, because this process is sometimes not defined in the companies. So sometimes the wrong people end up with the access to the private keys, which is especially a problem when there are, for example, changes in the company, when the developers change, when the CTO is fired and replaced by another. It's very easy to mess up with the private keys and end up with insider job later. And it was a case in some of the hacks. So yeah, another thing, you have this private key stored in the server, someone can hack it, someone, can steal access to your email, then somehow get access to your server. Quite a mess, and that's quite a problem for the private key. And you may think that the bridges just need this, let's say centralized bridges just need this one approval for transaction, and that's it, but that's actually not the full picture. Usually there are other things in a smart contract which are also using the private keys and signatures. For example, upgradability in a smart contracts in the bridges. This is also a huge problem. Even if you have a trustless bridge, but you have implemented upgradability in this trustless bridge, it can still be hacked if your private key leaks, because when you can upgrade the smart contract, you can basically steal everything what is locked in the smart contract, and it was also a case. Okay, so fortunately for a few years, from 2 years, I think, we have a pretty good standard when it comes to the storing of the private keys and everything regarding them. It's called Cryptocurrency Security Standard, which covers everything when it comes to private key. So I won't be reinventing the wheel, but of course you should have few private keys, multi-signature if possible. If you need to store this private key on a server, you should store it in hardware security modules whenever possible. Right now, a lot of data centers support it. So in general, you should never have this access to the private key. I mean, you can use it to sign something, but option to export it shouldn't be an option if you care about the security of a private key, because in other case, there's always a risk that it will leak somehow, or even some employee will just get access to it, copy it just in case. So the best approach would be just to never have direct access to it, or just use a different machine for signing. So yeah, I recommend highly to check this cryptocurrency security standard when it comes to the private key security. Okay, and there is this second part, the smart contracts. And the reason they're hacked, there are many of them. And From my experience as an auditor, especially that I was auditing few bridges, the huge issue is lack of advanced testing. You know, when a project comes for an audit and I see that they have like 10 tests in their project and the code base is huge, I already know there will be a lot of issues, a lot of problems, and yeah, so a lot of projects don't really care about tests, and this is like one of the most important things. And I'm not talking about the simple tests like unit testing or integration tests. I'm also talking about this more advanced one, like a fuzzing. You know, we had a presentation about this 3 hours before, and there are other tools which are able to help with that, like the static analysis and some online services. So, you know, if I see that the project is not using them, this is usually a bad sign that there will be issues. This is especially problematic when there are new changes introduced into smart contracts. So a new feature is implemented, and you know there were not tests which were checking how some components would react to this issue, and then you know by introducing this new issue and this new feature, the new issues are introduced, and then we end up with, you know, even with some very minor change, we end up with introducing a critical issue in a smart contract. After upgrade, all the funds can be lost. In many cases, when the protocol was hacked, you know, the issue itself was pretty simple, like, you know, incorrect authorization, but the given protocol didn't go for the audit. Right now, you know, I don't imagine to create a bridge or basically any protocol without doing an audit. Even if I decided to build something myself, I would go for an audit to the third-party company, because it's almost impossible to, you know, find all the issues by yourself. You need to spend really a lot of time, you know, to think about all edge cases, everything, what's going on. And yeah, almost every project which existed, like Bitcoin, Ethereum, Solana, they all had issues. So with bridges, which are especially complex, you know, the audit is basically must-have. You know, I don't imagine it. For example, some of those bridges could have, you know, lost $100 million in hack. They didn't have audits. Just unimaginable that, you know, hold so much money and you don't do it. Okay, and the other thing also, you know, regarding those new features is the problem that even, some projects are doing this audit at a very early stage, but then they introduce new chains, new features, which are working differently, and they don't do a second audit. So they often think, you know, that the changes are minor, but in that ends up working totally different on a different ecosystem, and they are introducing new issues. So, you know, whenever you change something, you add new logic, write test, go for the audit, or, you know, just have cooperate with Web3 auditor all the time, or have some cybersecurity expert in your team. That's my recommendation. Okay, so of course, you know, if you want to deal with this kind of issue, you need to test a lot. Like, this is the most important thing. This is, you know, why you know that the project is good or not in 5 minutes, usually, you know, rule of thumb. A lot of tests, integration tests, fast tests, and tests in real environments. You know, the more advanced tools you use, the better. There are many projects specializing in delivery of amazing tools. Audits, you know, they are necessary for most of the projects right now because they are very complex. And, you know, if you plan to do anything more than just launching a token from Open Zeppelin library, you should go for an audit. That's my recommendation in this case. Bug bounty programs, yeah, they work pretty well. And I don't know why so many projects don't have them. For me, it also is right now a must-have for every Web3 project, even if you have that, you know, you don't have any issues. I also think that, you know, I'm not sure exactly how it works. It's a good question, but even in case if the private key is somehow, as a hacker, you are able to somehow steal the private key, you should also be able, to get some payment in bug bounty. Of course, it's hard to implement, but something like this should exist. You have a private key, you can claim a bounty, or maybe even creating something on-chain bounties, like, you have private key, you can steal this, that's your bounty, but, leave the other funds. Don't touch the other funds, because that would be criminal. Okay, and another important thing for a smart contract is to incorporate as many, okay, maybe not as many, but incorporate a mechanism to pause smart contract in case of attack or some attack detection. Right now we have few platforms which offer such functionality to monitor smart contracts, to execute a code when you see that something is going wrong. And it's very useful because many attacks require a lot of transactions to steal funds from a smart contract. For example, which one was it? Nomad, yeah. In the case of the Nomad, it was hundreds of transactions had to be done to drain the funds from the Nomad breach, so such to prevent it. And we had an amazing presentation about it 3 hours before. Okay, and there's also, when a bridge is operating on multiple chains, and there are some bridges and some protocols which support like 70 chains right now, there's always this risk of 51% attack against a blockchain, not a bridge in this case. I don't think there was any case about this when someone abused bridge. There was a case like this, but they abused exchange and it was some fork of the Bitcoin. But in case of the bridges, there is this hypothetical risk that if someone can somehow manipulate consensus and revert few blocks, then potentially a breach could be a perfect target for such attack. If one of these 70 supported protocols had this bug in consensus, it can lead to stealing a lot of funds from the entire breach. Because the breach is at most as secure as the least secure protocol it operates in. However, if you combine it with these monitoring services, then you can prevent such scenarios. If you see that something wrong is going to blockchain, if you have active monitoring, then you can just pause operation of entire breach. And I think this is a trend, and this is how the future of smart contract will looks like. We'll have this monitoring services, and something goes wrong, you just stop operating, and when you fix everything, you just resume your smart contract or just upgrade it. Okay, so going back to this, to other things which we can do to increase the security. So as I said, the monitoring and prevention, that's in my opinion the most important thing at this moment. And it should be implemented by default right now if you are creating a new product. And delays, whenever it would also have, not many protocols integrated, but whenever you do any high-value operation, it's good to add even a 1-minute delay. It's hard to implement, not really user-friendly, but if you combine it with monitoring service, which can prevent some malicious operation, then a delay can solve a lot of problems. So even a minute can make a huge difference. Okay, there's amazing risk analysis of currently working 34 bridges. It's from l2bit.com. So I read it, and I checked most of the issues which are potentially, existing in a given protocol, which could lead to loss of the funds or some other issues like censorship. So I summarized most important of those issues. Okay, and okay, so let me quickly go over them because we won't have time to go for every kind of issues. Okay, so the very high problem for the current bridge implementations, working mostly of Ethereum, is potentially fraudulent message relay. There were found 18 issues like this in the protocols listed on L2Bit. So, whenever validators decide to relay a fake message, which wasn't, signed correctly, in many cases it will allow to mint more tokens than were locked. Yeah, in general, even if there are multiple validators, there's always this risk that they will, somehow try to abuse the protocol. Okay, we had the cases of unauthorized token minting. So the funds can be stolen if validators decide to mint more tokens than is locked on Ethereum. Yeah, still the case. If we have 5 of 9 and 5 validators agree, they can, bypass the limits. Another one. So as I said before, malicious contract upgrade. This is a huge problem. Usually, it's hard to, even if protocol is having some advanced decentralized methods, if in the end a single private key is controlling upgradability mechanism of a smart contract, it's like a centralized breach, and hacks like this happen. So it's a very important aspect to look for. So it's not just the code, but how you deploy it. Okay, we had the cases with unverified contracts. So many protocols don't share the source code of their smart contract. So if there's an issue, if the smart contract wasn't audited, so there's a risk that the funds of the user can be lost. There were 9 cases like this. Okay, validator node collusion. So, some protocols use optimistic agreement to transfer user fund, validation proof. So, if the validators nodes decide to abuse this mechanism, take over it, then another case where the funds can be lost. We have the case mostly for the centralized bridges that admin owner of the private key can remove the funds from the bridge escrow. The bridge has some delay mechanism which they use to secure the funds. The admins usually can also abuse it, so quite hard to implement it. The key management, if some validator lose just 1 or 2 keys, the bridge will stop operating because there's no recovery mechanism in it. There's high risk of transaction censorship. If validators decide to stop processing a given transaction, just some of them, sometimes even one validator, then such user can be excluded from the protocol, and he won't be able to recover his funds even if he tries to send it. Okay, there's a risk of validators that if they need to approve every message with the signature, if they decide that we are not relaying messages, then again we have a case where the funds can be lost. There's liquidity issues that in some cases protocols are combined with some DeFis. If they have a problem with liquidity, the funds of the users can be lost. Similar case for Oracle manipulation, that if the protocol relies on Oracle and Oracle is starting to send malicious data, funds of the user can be lost. And in the last case, if there's insufficient validation, then there's some protocols need to mark if they're using optimistic validation, they need to mark if the transaction was correct or not. If they don't do it, then the funds again can be lost. Okay, and bridges are attractive because they hold a lot of assets. They are quite complex. It's easy to make a mistake, and usually if you hack one bridge, you can easily transfer funds to the other protocols. And last thing I want to tell you, there's a new trend about Bitcoin layer 2s, which are not the same layer 2s on Ethereum. They're kind of the layer 2, but they're mostly like a safe chain. And there are a lot of bridges very poorly implemented in this area because most of people just lie about functionalities. They are not trustless. So believe me, there will be a lot of hacks over there, and the first one already happened. So L2 Watch, you can check how many Bitcoin layer 2 bridges are there. So that's all. Thank you for listening. And unfortunately, we don't have the time for the questions. Thank you.
Thank you, Martin.